Hello everyone, welcome to today's session. In today's demo, we're going to walk through one of the most essential security services in AWS, that is Identity and Access Management or IAM. And to make this fun and realistic, we're going to follow a small startup called CoffeeCo as they move their new coffee delivery app into AWS. We'll set up their users, groups, roles, and permission policies, just like you would do in a real environment. So, let's jump right in. But before you move on with the session, make sure that you've subscribed to IP Specialist on YouTube and don't forget to hit the bell icon for updates. Now, before we start clicking around the console, let's quickly understand what IAM actually is. AWS IAM stands for Identity and Access Management. It controls two things: authentication, that means who are you, and authorization, that means what you can do. In other words, IAM makes sure the right people have the right access to the right resources. IAM uses four main building blocks: users, groups, roles, and policies. And we'll explore all four today using our CoffeeCo story so you see how this works in real world. Alright, so CoffeeCo has hired three new team members: Alice, the developer, Bob, the tester, and Carol, the administrator. Let's create them inside AWS. Alright, so this is the AWS console. Over here, I'll go and click on IAM. This is the IAM dashboard. On the left hand side, go and click on users. Then over here, we're going to click on create user. I'll start with Alice and name her Alice Dev. So let's type Alice Dev. Now if you want Alice to be able to access the console where we are right now, we'll need to tick this box. Next, we're going to create a custom password. For that, we're going to select custom password and enter a new password for Alice. Then we'll click on next. And right now we do not need to deal with permissions and roles and stuff like that. So we're just going to click on next. And then review and click on create user. Alright, so over here you can see that user has been successfully created. Now we're going to repeat the same steps to create the other two users, Bob and Carol. Alright, so we have successfully created our three IAM users, that is Alice Dev, Bob Test, and Carol Admin. But none of them can do anything yet. So let's move on to groups. So, in a real company, you don't want to give permissions user by user. That becomes unmanageable very quickly. Instead, you assign people to groups and then give permissions to those groups. For CoffeeCo, we'll create three groups: developer, tester, and admin. Alright, so on the left hand side, we'll click on user groups and click on create group. First, we're going to create a group called developers, and then we can add users from this screen. So we're going to create a group called developer and we're going to add Alice Dev and click on create user group. So the developer user group has been successfully created. Alright, now following the same steps, we're going to create two more groups. We're going to create a group called tester and we're going to add Bob in it, and a new group called admin, and we're going to add Carol in that group. So we have successfully created our three user groups: admin, tester, and developer. And we have also added our users in that group. And just like that, our company structure is taking shape. Now that we have created our users and organized them into groups, there's still one big question: what can these users actually do in AWS? Right now, the answer is nothing. And that's intentional. IAM starts with zero permissions for security reasons. To give someone access, we use what's called a permission policy. A permission policy is simply a set of rules written in JSON format. But don't worry, you don't need to write JSON yourself to understand how it works. Each policy answers a few basic questions. First, it defines the effect. This tells AWS whether the rule should allow the action or deny it. Second, it lists the actions. Actions describe what the user is allowed to do. Things like S3 get object to download the objects inside the bucket, or S3 list bucket to see the list of objects inside the bucket. Third, it specifies the resources the policy applies to. For example, a policy might allow access to all S3 buckets or only to a specific bucket, or it might give permissions only to one particular EC2 instance. Finally, some policies include conditions. Conditions let you narrow the rules. For example, allowing a user to access S3 only from a company IP address or allowing an action only if the request is encrypted. It's like adding extra filters to tighten security. The great news is that AWS provides many pre-built managed policies for the most common use cases like S3 read-only access, EC2 full access, or administrator permissions. So instead of writing JSON, we can simply attach these managed policies to our users, groups, or roles. Now that we understand what a permission policy is and how it works, let's go ahead and attach the right policies to our CoffeeCo groups. Alright, now since Alice is a developer, so she needs access to services like S3 and Lambda. We'll go inside the group of developer, and then over here we'll click on permissions, and then on the right hand side we're going to click on add permissions and click on attach policies. Over here we're going to search for our policy called Amazon S3 full access. Now to add this policy, just click on the checkbox. Next we're going to search for the other policy we want to add, AWS Lambda full access. And then we're going to click on the checkbox to add it and click on attach policies. Now as you can see that both the policies has been successfully attached to the user group. Now we'll go back again to the users group and attach a policy to the tester group. Click on tester and over here click on permissions, add permission, attach policy. We're going to search for CloudWatch read-only access policy, add it and click on attach policies. So the policy has been successfully attached. Now we'll go back again to users group. And lastly, Carol, the admin, should have full administrative permissions. So we'll go inside the admin group, click on permissions, add permissions, attach policy, and we'll give her full administrative access. And we'll click on attach policies. Now finally, each user inherits the permissions of the group they belong to. This is clean, scalable, and the recommended AWS practice. Now, let's talk about roles. Roles are different from users. A user represents a human being. A role represents a set of permissions that someone or something can temporarily assume. So why do roles exist? Because AWS resources like EC2 or Lambda also need permissions. You don't want to store permanent passwords or access keys inside an EC2 instance. Instead, the instance assumes a role and gets temporary permissions from IAM. Roles also enable cross-account access and identity federation. For CoffeeCo, our EC2 based application needs to access S3. So let's create a role for it. Now over here on the left hand side, we'll click on roles and click on create role. Now for the trusted entity, I'll choose AWS service. And then over here, we're going to select the EC2 service. This means EC2 instances will be allowed to assume this role. Next. Now over here, I'll attach the Amazon S3 full access policy because the CoffeeCo application needs to read and write files in S3. So we're going to search for Amazon S3 full access policy. We're going to select it and click on next. Now I'm going to name the role CoffeeCo EC2 S3 role. Now over here you'll notice two things. The trust policy defines who can assume the role, in this case EC2. And the permission policy defines what can the role do, in this case S3 access. This is the correct and secure way to give your EC2 instances access to AWS services. So let's click on create role. And as you can see that we've successfully created a role as well. So we have attached a whole bunch of policies to different things. But let's just test out how it works for Bob. So I'll log out of my current account and log back in as Bob. Remember, Bob is a tester and we only gave him CloudWatch read-only access. Now in order to log in as Bob, we're going to go in users, search for Bob test, and we're going to copy this ARN, and we're going to log out from our current account. Remember, our username is Bob test. So as you can see that we have successfully logged in as Bob test. And you remember that he's just a tester and we gave him only CloudWatch read-only access. So we'll go and navigate to CloudWatch. So this is the dashboard of the CloudWatch. Now we'll just move around here and there and we can see that Bob is able to view the log groups. He can also create a log group. He can create alarms. And as you can see that everything is working as expected. Now let's quickly try to access S3. So we'll go to the console dashboard. We're going to search for S3. Now as you can see that Bob is unable to access any of the buckets. The access is denied. So everything is working as we wanted. As you can see, Bob cannot access S3 at all. That's because he only has CloudWatch read-only permissions. This is exactly why IAM's principle of least privilege is so important. Users only get the permissions they need. And that's it. In this demo, we explained what IAM is, created users for CoffeeCo, organized them into groups, attached permission policies, and created a role for EC2 to securely access S3. This is the foundation of secure AWS access management. That concludes our session for today. Thank you for watching this video. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel. And also share it with your colleagues or friends who might benefit from this information. If you have any questions or topics that you would like us to cover in the future videos, feel free to leave a comment below. Your feedback is very valuable to us.